Good morning. Today's topic is the subtle difference between activated complex and transition state. Students of chemical kinetics are familiar with the terms activated complex and transition state, and they consider these terms alike and do not bother about any distinction between these two terms. But a closer scrutiny reveals that there is a slight difference between activated complex and transition state, as illustrated in the explanation of a statement question written here. Statement 1: activated complex and transition state of a reaction are exactly the same. Statement 2: the activated complex passes through the transition state to yield the products. The answer to this statement question is S1 is wrong, but S2 is correct. Now let us see the explanation. The theories of reaction rates evolved in the order: the empirical Arrhenius theory, S. Arrhenius 1889. Empirical means an intelligent guesswork without any theoretical arguments. This theory nicely explains the effect of temperature on reaction rates and introduces two new kinetic parameters: energy of activation EA and pre-exponential factor A. Then comes the simple collision theory introduced by Max Strauss and William Lewis in 1918. It is based on the kinetic molecular theory of gases, and it introduces the concept of threshold energy, ETH. Then comes the activated complex theory, abbreviated as ACT, by Henry Eyring in 1935. Based on statistical mechanics, it introduces the concepts of activated complex and reaction coordinate. At the +2 level, we find that the ideas of all these three theories are mixed into one description in terms of a potential energy diagram, figure 3.7 of NCERT text, reproduced here, where potential energy of the reacting molecular system is plotted against reaction coordinate. Reaction coordinate can roughly be corresponding to the progress of the reaction. The reactants have to acquire some extra energy to reach a molecular stage of very high energy. The energy corresponding to that is the threshold energy before they can break down to the relatively stable products of lower energy. The difference between threshold energy and average energy of reactants is the energy of activation, whereas the difference between average energy of reactants and average energy of products is the heat of the reaction. Consider a general reaction A plus B, that is reactants giving C plus D products. According to ACT, the reaction mechanism involves two steps. The reactants combine to give an activated complex, and there is a reversible reaction between reactants and activated complex. The activated complex can decompose to products by step 2. Essence of activated complex theory is that there is always an equilibrium between the reactant molecules and the activated complex. The activated complex can either revert to the reactants by the backward reaction or change to products by step 2. The activated complex is simply just another molecular species of very high energy. The high energy comes from partial breaking of its covalent bonds in this so-called supermolecule. It possesses all the usual types of molecular motions like translation, rotation, and vibration. Apart from this very high energy, the activated complex molecule has one special type of motion. This motion can be described either as a vibration or a translation, with respect to which the activated complex is so unstable that the only outcome of this motion is its breakdown to give the product molecules. Such a stage of activated complex undergoing this special motion is called transition state. Thus, the subtle difference between activated complex and transition state is that ordinary activated complex molecules can equilibrate with the reactants, but once the activated complex reaches a stage of transition state, it is in a point or stage of motion that it can never return to ordinary activated complex molecules capable of equilibrating with reactants. In short, transition state can never return back to reactants, while activated complex can return to reactants. This difference may look rather trivial, but it is worth knowing this subtle difference between the terms activated complex and transition state. Thank you. See you later with other videos.